Welcome to TriEmbed, January 10th, 2022. And so we have a new problem of the month. Let's see, share screen. All right, can everyone see my screen?
Yeah.
Yes.
Yeah, we can see it. No problem.
Great. All right. So the problem this month, I don't know, most of you have seen presentations on my Sandboni, which is a Zamboni for a sand-covered horse riding rink. Some of you have seen it in person. It's a device that gets towed behind some kind of a vehicle, and it's supposed to be smart enough to keep the blade at a constant altitude. So the problem this month is I would like to know whether I'm pushing along a blob of sand in front of the blade or whether I'm up in the air doing nothing. People are very good at detecting this. Machines not so good. So any ideas?
So nobody will be in the Zamboni, just be running autonomously?
Yes, let's say that. I mean, if you have a great solution that involves, I mean, it can't be, well, look to see if there's a pile of sand in front of the blade. That's...
I was wondering if deflection of the blade or pressure on the blade would be an easy way to know if the blade's engaged with the sand or not.
Strain gauges.
Yeah, strain gauges on whatever holds the blade in place.
Okay, that's a great idea. So to detect a tilt of the blade.
I wonder if the harmonics that are involved with the blade when it's engaged with the sand might stop vibrating.
Or even just the sound of it engaged with the sound. I mean, put a microphone on it.
Yeah.
Yeah, because it's going to be vibrating with the motion of the Zamboni machinery itself versus when it's engaged with the sand, it's going to have a different
so the sand will dampen
harmonic.
You could
of the blade.
And there'll be a scraping sound.
An ultrasonic sensor pointing down that gives you the distance, and you can calibrate it so you know where the bottom of the blade is.
Well, but that doesn't work. If you look at so there's two situations on the left, right? The one at the top is where I'm scraping up new sand, and the pile in front of the blade is growing, is accreting, right? And then the one below that, the pile is flowing under the blade because it's above the surface of the ground. And so it's not scraping into...
And it's depositing sand.
The firm dirt. So it's just
an ultrasonic might still give that to you if you're looking at the level right where it touches the blade.
You could just look fore and aft.
Yeah, fore and aft can also give you exactly how much you're scraping out.
Or depositing. Actually, fore and aft seems like a really good solution. It gives you more information than just, are you scraping?
Okay.
I don't know if that information is helpful to you, but it gets you more.
Yeah, well, I mean, there's a lot a lot of things I want to collect, whether or not it's useful. A lot of times I won't know that until later on.
I mean,
So
you could use a float.
a float.
I say that kind of ironically, but sure, there are things that would skitter across sand. A flat piece of plastic or wood would give you a level, and it would also give you a level if it was light enough, even where the sand is accreting against the front or has accreted across the front of the blade. So it wouldn't literally float like on water, but it's the same as being displaced by sand and gives you a physical vertical measurement.
Okay, so a float right in front of the blade might detect the pile of sand.
Yep.
Yeah, I don't know how you deal with that mechanically though, because it'd have to move kind of with the blade, but in front of it.
But it would have to
You mount
almost
it to
be
the
on the
blade.
front edge of the blade. I mean, like moving up and down in a track on the blade, like planing, like a plane in water.
Yep.
It's just pushed up by the sand or dropped down and probably jam a lot.
So
Yeah,
if you have a little
I have
thing
the feeling that'd be a mechanical nightmare.
Yeah.
if you had one that was dragging at the backside, lower edge of the blade, right, in the case on the right, it's going to be tipped down into that void, the
Yeah.
air between them.
Right.
And the
Right.
two
If you just
cases
want to
on
know
the
if you're in the air or
left,
not, that would work.
the two cases on the left, it's going to be dragging along the sand. It wouldn't distinguish the two cases on the left, but I wasn't asking
Right.
for that distinction at the moment. Now, ultrasonic sensors, I've used them before, like on, where were we?
How well do they work on sand, loose sand?
Yeah, I think they don't.
Right.
I
A
was in a
drag on the
place where
back might actually work better.
what
A float hanging off the back might actually work better than an ultrasonic.
How about infrared?
Yep.
You're not going to get a good reflection. The sand's going to be a very bad reflector.
Well, don't forget sand though is like glass. So
right.
It depends on how the lighting is.
Infrared, but it'll reflect it noisily.
I mean,
just put a camera on it and throw an AI at it.
Okay. Open CV or something. Yep, that would work.
There's a XKCD that says all you have to do is do it manually, and then you can claim you threw a neural net at it.
A big, powerful neural net.
Or a very unpowerful neural net, depending upon.
I'll be back in
your point of view. So I was doing a wall following robot, and I think we were at State. I'm not sure. I think that's where it was. And they had run the carpet up the side of the wall as like the shoe molding along the at the bottom of the wall. And that did not reflect the ultrasound at all. And there was a place where the carpet stopped and a regular vinyl plasticky thing was, and it did just fine off the vinyl, but when it hit the carpet, it totally didn't see it. So I suspect that sand or snow or a lot of these things that are loose and filled with air or not might not reflect very well. And that probably applies to IR somewhat as well.
What if you, instead of having quote unquote a float, what if you had a wheel in front, excuse me, in front of and behind the blade, calibrated to know where the blade was? So if the wheel that was in front was riding higher than the wheel in the back, you know that you're subtracting material. If you know that both of them are below the level of the blade, you know that you're in the above the surface. And if the front wheel is below the level of the back one, you know that you're depositing material.
So on some kind of suspension so that it can flow up as the pile of dirt
Exactly.
accumulates.
Like on a big plastic wheel, you know, like the ones that you put on the on a beach wagon to carry your stuff out to the coast. Big flat wheel, so it's not going to dig in, and it's free to float up and down. And you put a electronic sensor on that to determine what the height is.
Measure the angle of the thing holding the wheel. Okay.
I have a little rolling thing that I use to smooth down aluminum foil that just kind of it's about a 4-inch wide roller, which is relatively cheap. That would be, that would give you a good surface to work off of.
So like a ink roller for
an ink roller,
doing printmaking or something.
Yep, exactly what it is.
Okay. All right. Any other ideas? This is a very dusty, dirty environment. I mean, I could imagine putting a small mirror at the bottom of the blade and try to bounce some kind of a light beam off of that. And it would probably work great the very first time. And then it would get all dusty and it wouldn't work.
Yeah, and even a wheel could easily get sand in the, if it's a small wheel, sand in the axle, and it could start getting stuck.
I think you'd get a moderately good signal off the ultrasonics. I mean, the sound wave is still orders of magnitude bigger than the grains of sand.
Yeah, you could try ultrasonic and infrared. Either one of those two might come up with something.
Okay. All right. Any other ideas? All right.
Off topic, but do you have a welding setup at your place yet?
Welding. I do not plan on doing welding at my house.
Okay.
My garage is full of things that are combustible. And so I will either continue taking classes at Durham Tech and use their lab, their facilities, or I will go to Shop Space, a maker space on Capitol Boulevard inside the Beltline. They have open studio time, and you can buy a punch card with 10 hours on it or something and go in and use the space, and they'll punch your card as you use it.
Well, that's kind of cool, actually.
The welders at those places, the welders at those places are probably substantially better than the ones that I can offer you, but you're welcome to borrow mine. How flammable is your shop? Are we
We'll
talking
find out.
gases and such, or are we talking about woodworking things?
Cardboard boxes, sawdust.
Yeah, no flammable. I wouldn't worry about it.
You're fine.
Yeah.
Yeah,
My
Not a
favorite
problem.
situation is when the welder's fan blows up the sawdust in the air. Then it's especially great to set off a spark. Actually,
Yeah.
one of the most magical things I ever did with a welder, just to share a story, and then I'll be really quiet, is I did it on purpose. I got a really good long breathing tube, like a snorkel, and put a valve on it so I could breathe in one and out the other so that I wouldn't breathe stale air. And I had gotten a bunch of galvanized steel. And so I pulled my welder out in the driveway and I welded 2 pieces of galvanized steel. I didn't even weld them together. I just welded a bead across them. So galvanized steel is covered in zinc.
Yes,
And
not
zinc,
good.
which is not good to breathe, right? I mean, it's a way to make yourself sick really fast. But it's amazing when you vaporize an awful lot of zinc. For 30 feet around me, 20 feet around me, the air was filled with zinc oxide snow. It was the most beautiful thing. And it all settled out really quickly and I cleaned it up. But it was the most amazing thing. You just don't want anyone nearby while you're doing it. Once it's precipitated out of the air as zinc oxide, it's no big deal, right? It's just like sunscreen that's falling out of the air. But while it's in gaseous form, you really don't want to be breathing it. But it's an amazing thing to do as long as you set up your breathing before you do it.
Yeah, that's kind of important.
I did it to demonstrate to some people just what would happen if they made this mistake. So,
Well, you didn't complete the demonstration.
you're right. I left out the part of what it looks like if you don't actually set up the breathing ahead of time.
Yeah, I mean, it was an incomplete demonstration.
But the amount of zinc oxide that precipitated out of the air made it really clear how much zinc gas you would be breathing if you did this. In fact, I suspect it made it more dramatic than it really is.
No,
So
death would be more dramatic.
if you go buy not a galvanized bolt, but just a regular bolt from the hardware store, right?
Mhm.
It has a thin coating of zinc, not the real thick that you get on a galvanized. How dangerous is that? Is that just as bad?
If you were going to spend 8 hours a day welding those, I might think about it. If you're going to weld 2 of them, I wouldn't even give it another thought.
Okay.
I'm not an expert, but I've done it lots of times and I'm still breathing.
Just
Lots
hold
of
your
times,
breath.
meaning 8 times over 15 years.
Okay.
I don't know. Other people may be way more expert than me. If any of you are, please tell me I'm wrong.
I read a thing. Some guy was gonna do that, and he put his bolt in vinegar overnight,
Yeah.
which evidently removed most of the zinc, and then he did his welding and then painted it or something. So I don't know if that helps or not.
It would get rid of the zinc.
Well, that was the goal.
And your body will chelate a certain amount of zinc in the first place. It's just that you don't, if you're a professional welder, you don't want to sit there welding zinc all day. And as an amateur, you don't want to do any more of it than you need to, right?
Yeah, it's not something you do for entertainment value. Let's see what happens.
Right. But usually if you were to give yourself the zinc flu, you're over it in 3 or 4 days, right? Your body does chelate it out. It's just, but who wants the flu for 3 or 4 days, right?
Yep.
Well, this is good to think about.
Don't do that with lead, though.
No, that doesn't chelate.
It's a slightly more difficult process.
Okay, so next on the agenda is, I guess the league is going to do some kind of a roundtable about how things are going.
Fellow Gypster has disappeared upon us.
Yeah, I was going to say, do we still have Pete? We need him.
I am here.
At least in spirit.
Well, I realized my ugly face was back on the screen after he stopped the sharing, and I thought I would cut you guys some slack. So, for those, so is there anybody in attendance who is not familiar with what's going on? Bill, what about you?
Bill, if you're talking, you're muted.
Apparently,
Okay. I don't know if this is the Bill, the Australian Bill, Bill Farrow.
Yes.
Not sure. We think it's Bill Farrow.
Yeah.
Okay. Well, anyway,
He unmuted, so
very.
maybe he'll say something. You
Oh,
there,
it's
Bill?
unmuted. Hello? Okay. We can't hear you, so unfortunately, feel free to break in. But the high order bits are as follows. Nick came up with the idea of creating a kind of a TriEmbed community project centered around field programmable gate arrays in combination with what is pretty well recognized as the dominant low-end single board computer floating around these days, which are based on the ESP32 dual processor, and that has kind of morphed into the creation of a working group, and the working group has had 2 face-to-face meetings. The first one, November 22nd, was pretty much entirely people getting to know each other, and a little bit of discussion and some show and tell. And then the second meeting on December 20th was a little more people getting to know each other. We had some additional new people, and we started discussing in broad terms things of interest. And initially, Nick and I were looking at gate arrays provided by a vendor called GoWin, Gowin. And while this was happening, Renesas announced the acquisition of a company called Dialog, and Dialog in turn announced a bunch of, or Renesas announced that by virtue of that, they now offer some mixed signal FPGAs. And the very attractive aspect of these things from our point of view is that they're cheap as dirt. They're relatively simple. It's possible to understand what they do without reading a 1,500-page data sheet. And the tools for synthesizing them are extremely good. Very, very simple drag and drop graphical interface. And so that kind of became the big shiny thing that seemed like a more interesting matchup to start with, as we talked about progressing from a relatively simple combination of ESP32 and some number of FPGAs and some peripheral chips to do simple things like make oscilloscopes or data acquisition gadgets, various things along those lines. And so we've kind of got parallel tracks now where we're still interested in the go-in parts, which are strictly digital, have order magnitude thousands to tens of thousands of gates. But the Dialog FPGAs with their mixed signal aspect and their very good accessibility, I should say, have kind of captured our attention. So the one sticking point with these FPGAs is programming them. I went and dug up the dirt on the forum, and what happened is that the programmers that were made by Dialog turned out to be defective, and they were withdrawn from the market. Right. So these guys, they're not out to conquer the world, because first they announced these chips without having any for sale. Rob Mackey and I bought the United States supply of one of the parts, totaling 5 dozen. And on the other hand, the programmers that they put out, I was about this close to buying 4 of these programmers when my order was back. Instead of them showing up, they said they're back ordered and we don't know when they're showing up. And as I said, I looked up on the forum and I found a thread where the company has basically said they're basically doing a recall on the current design, and they're working on new programmers. Well, Nick was not patient enough to wait for that, so he's figured out how to program the chips directly using I2C, and oddly enough using an ESP32, since the target development board, part of the intention with that would be for the development board, the ESP32 side of the development board, to be able to program the FPGAs on the board. Some of them might be pre-programmed and have a fixed function, but others would definitely be targeted. Well, in the meantime, we found that the cookbook for programming the FPGAs via a script, Arduino program, turned out to be defective. And again, I went to the forum and I found them discussing that, and sure enough, they acknowledged that it was messed up. So and my phone is about to run out of battery. Great. So anyway, what was I saying? So they put out a new sketch and app note explaining how to do the programming using I2C. And that's what Nick's using now. And he has designed a programmer that's extremely interesting, in my opinion, in which you run this ESP32, and the ESP32 creates a Wi-Fi access point, and you point your web browser to that access point and put in a password of some sort to get access to it, so that anybody can't get into and reprogram your FPGAs. And then you literally upload the program that's come out of the synthesis tool, and it flashes, puts that into the non-volatile memory of the FPGA. And then the next time the FPGA is powered up, as I understand it, it has the personality that you've given it. And that combination, the one missing piece of that is that quite a number of these parts are surface mount, very small, very, very, very fine pitch surface mount. They're really cruel and unusual. QFN, they're quad flat packs with no leads and a pitch of 0.4 millimeters, and unusually small packages, like say 2 by 3 millimeters and stuff like that. So I believe that the part that Rob and I got, from memory, it's like 2 by 3 millimeters with 24 leads, 24 pads, I should say. So it's extraordinarily bad to handle these things, but Dialog has made special sockets, programming sockets, where you can basically put the chip into the programming socket and program it without having to do any soldering or anything like that. And you can then feed the programmed chip into the assembly process. And where things stand right this moment is that the design is being prepared to go to Osh Park for just an initial run. And we're very interested to know if others would like to get their hands on one of these programmers and figure out a group buy. The boards will be very inexpensive. The ESP32, it's going to actually be an ESP-C3, which is the single RISC-V processor variety of the board that's extremely inexpensive. And the remaining piece, pardon me?
No, just you showing. Yeah, go ahead.
Yeah, the remaining piece though is the special socket gadget for holding the chips. And what we have in mind for that is to approach Dialog, show them what has been made,
And
get
we
them,
have the U.S. supply of their chip.
and that we have the U.S. supply of the 47004 V part, and also try to get them interested in donating some of those sockets for our use. They can be purchased, assuming that they're not defective. That's a joke, sorry, terrible joke. And from memory, they're in the $30 range. There are probably, how many flavors of those are there, Nick?
They're about 7, I think.
Yeah, so
they all go into the same header, so that if you program, once you've got the header down, you can program any device.
right. Yeah. So what we would ideally like to do is connect with Dialog, have a dialogue with Dialog, and get them interested in what we're trying to do. Because basically, we have, I should say, Nick has created something that will potentially open up the accessibility of this thing in a major way, and should create some excitement. And that's pretty much the status. So why don't you fill in the missing pieces, Nick?
Well, this is the ESP32ES, which is tiny. It's a full ESP32 chip, and the board itself, the program itself, would be the biggest thing on it's the header. There are some minor design things to do, but it is over-the-air flashable, so that you can update the code very easily. It's at the moment a very, very, very simple program. You point to a file, it downloads the file, flashes the device, and checks it and says I'm done. The ESP32 that we're planning to use in quantity 1, they're like $1.70. In quantity 100, they're a little cheaper. So the Osh Park board would maybe be an inch, maybe an inch and a half. The connector would be, whatever, 70 cents. Don't know what that would be, but you essentially have a programmer that should be in the parts cost less than $10. That's I don't think that a company like Dialog would promote an ESP chip, so we're kind of in a good place in terms of being able to mix components in a way that they are that we can do more easily than they can do. This is one of the ESP32 modules mounted on a carrier, and they're minuscule things. and pretty powerful at that. So I'm just sort of finishing up. I've got Pete wired up some of the dialogue chips. So we're in pretty good shape. And now whether we can get dialogue to respond, it turns out that some of the work on the dialogue chips was done locally, and I'm trying to get in touch with the people that did it. Don't know whether it was developed locally, but I traced back one of the programmers, and he was at NC State and is now at Lenovo. Very local. So I don't know what kind of political minefield we are potentially stepping into, but hell, what's your mind?
I can understand wanting to program these chips, but after you've programmed them, you have to put them in some kind of a board, right?
Well, the idea is that in order to, we can't at the moment program them. The idea is to do a very low cost board. You could take a program chip and essentially connect it into an ESP and have a very low cost sub $10 oscilloscope.
I think the idea is that if it's effectively a breakout board that has a programmer built in, is another way to think of it, is here's your FPGA on a breakout board with a programmer built in. That's a really interesting thing for a lot of people to get started with FPGAs on. If you're then going to go on to products, you might then design your own board and have them pick and placed on it. But if you're just going to learn about FPGAs or build free one-off projects, then this is a great way to be able to get your hands on it.
Okay, so the programmer is not a separate thing that the group is working on. It is the thing that the group is working on.
Well, it is, until we can program the chip, there's not much we can do. So,
right, but if you were suddenly able to, if you had a device that would program the chips,
then I would use it.
But you still have to put it on something that has an ESP32 that you can reprogram it.
Let me jump in on that. Okay. The parts that Rob Mackey and I sucked up out of Mauser are already mounted on breakout boards, and there are 3 other part numbers, or at least 3, maybe it might be more like 5, that are available in TSSOP 20 packages, which are quite easy to solder. And so there are about 6 different parts that are quite accessible, either by virtue of not needing the magic surface mount part socket, or by being able to use the relatively easy to solder TSOP. So for our purposes, unless we got into designs that required the very, very dense parts, we can defer that complexity. We can defer that issue. But you've made a very good point that the sticking point in my mind is after you've programmed this 2 by 3 millimeter part, who is going to assemble it? Because it's out of its tape and reel package. Now, I guess theoretically, can you put parts back into the tape and reel mechanism? Is that something that can be done? Anybody know that? Because unless it can be put back into the tape and reel, getting it into a pick and place machine in order to properly grab it and place it and so on is quite a trick. Plus,
well, it's got to get oriented right.
My if I was going to do if I was going to program these things for a real circuit, I would program them after they had been mounted. I would, it's all you have to do is apply power and the I2C connectors. So the what we're putting together is designed for initial prototyping in a production environment. You could take that same little thing, just apply 4 leads to the device and flash it in situ.
Right, you drop a header on it or something, or probes, and program it right there.
Yeah. Pogo sticks.
Pogo sticks,
Right.
and program it.
Yep.
Right, and for the other, for the ones that are in the TSSOP package, it is very straightforward to handle them manually. Yeah.
One of the things I think over the long haul we need to think about is we really do have a couple of different use cases, and we need to, they're all supportable. We need to keep them apart and realize they have different requirements. One use case is I want to program some of these and put them in my projects, and I don't want my projects to be any bigger or more power hungry than they need to be. Nick falls right into that category. He's going to program one and put it into his project, right? Yay. The other is I've never done an FPGA. The way I bought an Arduino to learn about microcontrollers, I want to buy a thing or get a thing that lets me play with FPGAs and hook it up to something and blink lights or make my weather station or whatever my thing is, right? If it were an Arduino, it'd be my weather station, whatever it is, right? And I don't mind that I have extra components on there. What I really want is that something makes it easy, like what actually Pete described Nick has done, where, oh, look, I can write my program on this ESP32, I can download it, I can upload it, or maybe I can just tell it to put it on, and I can now plug it into my project next to my flower plant, and I know I did something with an FPGA. If I decide to go into that career or change my career, or if I want to go production, I'll look more like Nick or Pete, and I'll start soldering in TSSOPs, or I'll get a pick and place and pogo sticks or whatever it is. But those are like 2 different families of why I would do this. And the requirements on the device we provide will be really different. The hobbyist who's saying, wow, I never knew I could do an FPGA and hasn't really done much, once that all-in-one package, this is easy, like the Raspberry Pi. Thank you, I plug it into my USB or I hook my Wi-Fi up and I have a thing that works and my lights blink. The Nick or the Pete or the me maybe even, it's like, okay, now how do I attach these to my project? I really don't need all the rest of that attached.
I'd go one more step and say that the Nick and the Pete and the Rob and Bill and some of the others have to do that putting together to make the thing for the person who wants to explore, right?
That part for sure. There's that in the middle.
Wait a sec. And the other point is this programmer that we're talking about, if you literally, instead of plugging it into the special socket, if you make it part of the target board that we've been describing in earlier meetings, you're done. In other words, if you put it on a board with some FPGAs that are tied together on the I2C bus, then they can be programmed as kind of a side effect.
I thought that's what I said, but okay.
You did say that. I'm just making it explicit that we have to design and make that all together board that has the functionality.
And if the header for the programmer also is the header for any number of little boards, then you can plug in whatever device you want to and see all the, you can produce a little board that plugs in and has your LEDs, a little board that plugs in has your scope, and these are all, again, hopefully sub $10 things. So it's the idea is the cardinal sin is over designing in this case. It's like, if you don't need it, don't put it on there. And if we had, and a lot depends upon what Dialogue's intentions are, but if we could become good friends with them they have at least advertise on their website sort of school discounts and that kind of stuff. So we could become the Raspberry Pi to their ARM core, and that is probably a good thing.
Got a question about the FPGA itself. How many times can this thing be reprogrammed?
Approximately 1,000.
About
1,000. Yeah, for the what they call multi-time program, they do offer one-time program parts.
No, I remember you guys talking about that.
Yeah.
Which are the ones you guys got?
Got some
Well,
of
we've got no. Nick has a bunch of one-time, and Rob and I have the multi-time.
Oh.
And we've given Nick some of the multi-time. One of the thought, as I visualize this, if Nick were to add some additional headers to his, if he were to bring out and expose not just a connection for the specialized socket, but a simple header that would plug onto another board, we've more or less got an initial iteration of an ESP32 that could connect to some larger board or like we've been describing earlier. So it seems like what I'm trying to say is that there's a standalone programmer idea, but there's also at least the model per se for the for a more complete board.
The programming modules, even though they only need 4 pins, have like a 10-pin header.
Yeah.
So we it's my intention to use as many of those pins, or at least put the ability to put jumpers into those pins, so you can do you could do a whole bunch more.
Yeah. Very good.
One question I did have listening, being lack of my involvement so far, is the FPGA. There's a processor on there, the ESP32, presumably for the application. But what is the FPGA reserved for? Is it just general purpose processing or
fun?
Fun. Good. Okay.
Yeah.
Well, that's great.
One of the FPGAs has, for example, 4 uncommitted amplifiers, an auto zeroing amplifier, and some essentially gain control elements. That would, I can think of dozens of things to do with that.
Sure.
Everything from an EEG, from an electric encephalograph to a, it's just the number of times you just need like a quick uncommitted amplifier and a comparator and maybe a regulator. And if you're paying 70 cents for that combination, that's a pretty powerful use case.
Yeah, these parts are obscenely inexpensive. They're in single quantities. They're neighborhood of $1, and fall down to about 50 cents in reel if you buy a reel.
And that's a couple of references. They've got, some of them have comparators, some of them have these uncommitted amplifiers. You pay that for a quad amplifier, and you've got 1,000 step to 1,000 step gain control devices, and a bunch of little up down counters and that kind of stuff. It's the particularly the C3. One of my use cases was as the power supply controller for that. It just, it's a very nice, simple. You can charge the battery, and it's very low power, so you can that's what kind of led me down this particular garden path, is that I needed some way to put a power controller onto the ESP32Cs, because the ones, the package I was using didn't have that. And it's like, oh, these are great. And then it's, okay, let's go into this particular garden. So that's sort of why I followed that. I personally have a couple projects that I would like to do with these. It's the ESP32 has a fairly nice 12-bit A to D converter on it, except it's got about an 80K input impedance, which makes it useless. You can't use it with a high impedance signal. You need to put an amplifier there. So if you need to re-reference your signal so that you've got something coming in at you want something coming in at half scale, so it's referenced to ground, all of that kind of stuff. Just for in the project that we were just discussing, it's got a fairly good zero crossing auto zeroing amplifier. You could throw, I think, I haven't done this, but I think you could throw a strain gauge on that from the looks of it, with absolutely no problem. And if you do that, then you've got, a strain gauge thingy going into an ESP32. You've got it is potentially a really quick drop-in solution to a whole bunch of niggling problems.
Essentially, you're programming a bunch of hardware to do various things that you would like to do without actually going out and buying custom hardware for each of those things.
Yep.
And all the breadboarding is done in software.
Right. Kind of software. It's not actually a programming language, though, I guess.
Yeah, I
I'm
mean,
still a little concerned about all the pieces that need to work. I mean, I tend to run exclusively Linux, so if it's, I know Pete said that there is a tool chain for Linux.
Yep, I run the tool.
Got to see what this is and how to set it up. And
the tool, I run the Linux tool chain, and I am, it's fairly impressive. What I have written for the ESP programmer is a web interface. It's a drop and drag web interface. You could run it from your iPhone.
So have you shared any of that anywhere yet? I haven't looked to see if it's on the GitHub.
No, I'm still, I'm still fine. It
wasn't a demand. It was just curious.
Yeah, no. I'm getting it to work. I'm getting it to work. With at least the first iteration board, one of the chip that we're using, the ESP chip, has the capacity to directly to accept USB signals, but they have to be level translated. What I want this board to be is as simple and cheap as possible. So it is my intention to only use the USB for the power supply. And so everything is, the web interface is it. There's nothing more. You don't, you plug the USB in to get power. There's keep it. If it doesn't need to be there, I ain't going to connect it. And that's, that's a little bit tricky, but I've got most of it running.
Cool.
All right. Thanks for that update. We can go to show and tell. How many people have show and tell tonight?
That's a good question.
I bought a desoldering station.
Okay. I have something to present. Carl said he has something. Anybody else want to do show and tell tonight?
I might have. Go ahead, Chuck. Go, Chuck.
All right. Yeah, I have a radio amateur radio, and it VHF, UHF, and it also has DMR capability, digital radio.
This is this is a receiver
It's a
or a
transmitter,
transceiver. It's a transceiver.
transceiver. Yeah, it has. I've never had power on it yet, and it still has the protective films, and I just took the plastic bag off of it. But anyhow, I can just two quick words on that. That's all. Kind of excited. It's a late Christmas present.
If there's any time left over, I just realized I could push a button on this. I'm having to do this Jitsi with my phone, and I could switch cameras and show you my reflow oven and my really amazing microscope, and one or two other things that might be of interest. But we're kind of pushing it on time, so I'll be the caboose if there's any time left.
Okay. Carl, do you want to go first?
Well, yeah, sure. So I decided, I just put this in the chat. That's the desoldering station that I got. It's on the FPGA. I got it. It's about $139. It seems to work really good. I had to watch a couple of videos of people that actually got it up and running. There are some caveats on how to actually get it to work correctly, which don't show up in their manual or anywhere else on that site. It's a pretty common one. You wouldn't know by going to that URL. They don't give a company name, but there is various companies that there is a company that actually makes this for a lot of other companies. So there's actually a lot of videos on it. It seems to work really well. I haven't used it a lot yet, but I have done a little bit of desoldering on double layer boards, and it seems to work fine. You do have to get a lot of replacement parts. All the filters get dirty really fast. So, I mean, that's normal, right? So if you're sucking solder through a filter, that filter is going to get dirty pretty fast.
So it has vacuum?
It has a vacuum. So this is not a, so there's two different kinds, right? There's a desoldering station and there's, geez, what's the other one called?
Rework?
A rework station, right. So rework stations are really used for very fine, so you would use that for like the chips that we were just talking about today. If you want to actually pull a surface level chip off, you use a rework station. But if you're doing through holes or bigger parts, you want a desoldering station. The rework stations tend to be more expensive. Although I have seen some cheap ones out there, I'd be careful what you find and what you buy. But they're only going to work for certain size parts because they come with different bits, and each bit is for a different size part. So it's rework stations you have to be careful about. Desoldering stations are just much better for all around desoldering different types of stuff. Theoretically, you could also do surface mount with it. It would be a bit more difficult to do it as long as it's the ones that have leads and not the ones that are surface mount underneath, right? Those will not work with a desoldering station because it's expecting a lead of some sort. With a desoldering station, this one comes with 3 bits. Each one is a different diameter. So I think there's a 0.8 millimeter, a millimeter, and a millimeter and a half. And that depends on the size of the pin you're trying to desolder, assuming they're through hole. That's why I say it might be a little dicey, even with a surface mount, but ones where the pins are underneath, you're never going to do it with this. The rework station literally heats up the whole board. And that's how it does it. It actually does it strictly by blowing extremely hot air on stuff. there's no like solder bit that gets hot like there is on a desoldering station. So it's essentially a soldering iron with a hole up the middle, and air gets sucked through that hole. That's what it is.
Yep.
I don't know. Maybe I can show you the handle if it's long enough. And I turn the camera. So
I mean, it's a soldering iron with a solder sucker built on it, right?
yeah, that's what it is. So you can't see here, but in the middle of that guy, there's a hole. Okay, and when you press the trigger, the solder goes. It gets hot as soon as you turn it on, and you can set the temperature on this one. It's about like I said, $139, which is not bad, and it works well. The temperature is anywhere from about 150 to 480. I find if you've got a ground trace, a ground plane, I mean, you probably want to do it at about 350. If you're just doing through hole stuff without a ground plane on it, then you could probably knock it down to about 320. This is all in Celsius. I tend to use Celsius for everything. I don't use Fahrenheit. Same thing when I measure stuff. I use the metric system. I seldom use the English system anymore. So when it comes to electronics, anyway. If I'm woodworking, I'll go to inches. But electronics, I tend to stick with the metric system. Anyway, so there's a glass thing. There's a filter in here. One of the guys said that if you can get some, what is it called, mineral wool, and put that in there, he says you're going to save your filters. And you can also so there's two filters, one on this side and one on the other side that actually goes into the front of the unit. Let me see. Sometimes my camera shuts off. I'm going to see if I can actually show you this thing.
Yeah, some fiberglass would work well too. I've used that.
Well, so there's my soldering station, and there's the desolder. So this guy's a desoldering station. That's my soldering station. I got both of those, by the way, through the same place. So I've got two power supplies over there. I got a bunch of crap on this table that I'm working on. So, but
as it should be.
Anyway, that's it for me. Not too much going on with that.
Okay, I'm going to share something again. So every year I've been showing you what I make for my nieces. This picture here is several years worth of usually 3D printed, some kind of a little puzzle thing to give some money to my nieces. They're old enough now that they probably don't need the money, but they enjoy the
puzzle.
The puzzle. So this is what I did this past Christmas.
How old are your nieces?
Oh, they're in their late 20s now.
Yeah.
And so
those that $500 is starting to pinch a little bit, huh?
Yeah. So the area here is where I roll up the paper money that I give them. These little yellow circles here are discs are important. So this is the shape of that disc. And I cut these out from 16 gauge stainless steel sheet. at Hangar 6 on their 500-watt fiber laser cutter. Does beautiful work. The kerf is incredibly thin. And so there's a little hole in the middle that I stick a straight pin through. And the center of gravity is somewhere around here. And so up and down is like on a line like that, and gravity holds it in place as it spins on the pin. So there's a lid that slides into that box, and it has some little projections here that engage with those tumblers. I've got, I have the device here, at least the 3D printed parts. Hopefully that's in focus.
You're still sharing your screen. I don't see your camera.
Well, you should still be able to see my picture somewhere, right?
Just your initials, I think.
Well, okay. Then you can't see it. I'll hold it up in a minute. So this is kind of what it looks like with the tumblers in their normal orientation with the box facing upwards. So they stick up a little bit and they engage with those projections that are on the bottom of the lid, and that keeps the lid from sliding out. And so the solution is to rotate the box so that this clipped edge of the tumbler here lines up with this layer of the 3D printed box, and that allows the projection to move that way on top of this first tumbler. And the tumblers are put in mirror image of each other, and so the angle to get them lined up is different. And so you manipulate it to get it past the first tumbler, and then you have to rotate it to a different angle to get that tumbler's flat spot lined up. And at that point, the whole thing slides open.
Who came up with the design? You?
So, I saw an Instructable probably 3 or 4 years ago of someone who did one of these. I forget whether it was fine woodworking or whether it was laser cut plywood. And so I kind of put the thought in my mind, and it simmered for a couple years. And,
as all good ideas do.
Yeah. And so I was trying to figure out what to do for this year. So here are the pieces. And this slides down in. And then I laser engraved their name on the lid here. You can't read this one because I've got 3 or 4 names laser engraved on top of one another. So I had to reprint in the lid. This is a subset of the box, for testing. I didn't need the whole thing. And you can kind of see the tumblers.
So how do you move them?
You can't because they're inside there, but as you turn this around at that layer right there, the first tumbler is now in line with the box, and the projections on the lid can slide under it. And then you have to turn it this way and continue.
Oh, so you got to move the lid out one thing at a time.
Yep.
because
Yep.
so the lid holds it in the first one in place, and
Yep.
then you have to move the other one, and then you can slide it back.
But how much do you put in this? I mean, are we talking real money or?
When they were 7 or 8 years old, it was real money. Now it's, a coffee or two. There's room for a lot of money if you wanted to put in a lot of money.
Sure, you put a $500 bill in there, right?
Yeah, write a check.
That's true.
All right, that's what I did this year. Now I have to start thinking about what I'm going to do for next year.
The check's only good for 90 days. It could take them a while to get the puzzle open.
No, checks a bit good for longer than that. I think they're 6 months to a year.
I'm sorry, I was just being foolish.
For a sufficient amount of money, I think the box becomes only a minor impediment.
Yep.
I'd be embarrassed to cash the check if I couldn't open the box.
I did print a very curious-looking square hole on the back, on the bottom of the box. It has no purpose other than to be
I
suggestive
wondered about that.
of a potential solution.
So you gave them no hints, huh?
Yeah, they don't get anything. They just get
They just get the box. That's it.
One year I made like a combination lock. It had 9 digits. And I gave him a Sudoku puzzle, and that was it. I didn't tell him how the Sudoku translates to the combination,
So have they both opened it yet? Oh, there are 2? I was just thinking maybe 2.
There are 2.
Yeah.
So they're actually in the mail. I never get these delivered before Christmas.
I know, every year you do the same thing.
That's right. So, last year, not last year, 2020, I didn't come up with the idea until December 23rd. I was almost ready to give up and say, well, that's the end of the puzzles, guys. I'm sorry. But on December 23rd, I came up with this really brilliant.
Was that the one where it was a laser cut? I remember you made some wooden ones and you laser cut them.
Nope, no, this was a 3D printed thing. If you want me to talk about that, I can. But let's let other people that have their show and tell proceed. So Pete wanted to say something, and who else? Carl already did his.
I think Chuck was going to show us a special radio.
Oh, yeah.
Yeah, here, let me put my camera on. Sure that you can actually see, or that there is much to see, but it's not big, it's small.
It's unfortunately backlit.
Yeah.
Like goes
Any
into
chance-
a car or a boat or whatever. It's not, obviously it doesn't go in your pocket.
No.
Yeah, that's better.
And it's 2 meters, 440, and actually has 220 as well, volts, but megahertz. So it's new. It has the analog, so it operates on analog repeaters, and it operates on the digital repeaters, the DMR, and it also supports APRS. So there's a satellite antenna that plugs into the back of it. Right here's a tiny little connector for a satellite. So it'll broadcast your position, and you can go to the APRS I think it's FR website and see where you've been. I'm just learning about the digital and the APRS stuff. The regular two-way repeater stuff is very familiar with that. So new dimension, and that's it.
I know the
Okay.
weather balloon to the edge of space people do the APRS radios to track their weather balloon tracks.
A couple of meetings ago, I asked about a spot welder for batteries, and since nobody had one, I invested in one. So I've now got the ability to weld 18650 batteries or other size batteries, and I've made myself a battery pack. This one happens to be 24 volts, capable of I think I saw 28 amps surge discharge for 30 seconds. 12 amps continuous.
That's for your new flashlight, right?
Yeah, exactly. No, this one's for the flashlight.
That is a spot welder.
Yeah. These are 38 120 cells, and they're called headway cells. With this 2S 4P pack, I have gotten sustained or not 1100 amp spot welds out of this new spot welder. So it's a guy
Kiloamps.
Germany, yes, 1.1 kiloamps. These cells have a surge discharge of 200 amps, like much stronger discharge. And I've managed to weld up the cell. I'm working on getting a charge or a tester to actually test what my calculated numbers are, what I expect are what I actually get out of the battery pack when I'm done.
And how thick is the nickel strapping? Did you say you were using 1 millimeter or?
Yes, I'm 0.3 millimeters. Nickel is about as thick as you can possibly get, but this welder has other people with more powerful batteries have been spot welding 0.2 millimeter nickel on top of copper strips because the copper just is so hard to spot weld that it's just almost impossible to do with a hobbyist or even an industrial level machine. You have to really go into the multiple tens of thousands of dollars to get to a spot welder that's capable of welding copper. But nickel strips on top of a copper strip, you can successfully spot weld that. I'm using 0.2.
So you mean you can actually put two strips on a battery and put the nickel strip on top of the copper and spot weld it right through to the battery?
Yes, that is. I have not successfully done that myself, but the Keen Labs forums, multiple people are doing such things because most of these people are building battery packs for e-bikes or
Right.
basically vehicles where they're looking for much higher surge currents. This one's for.
So they need the copper, right? Because it handles more current, I guess.
Yes. Yep. The batteries that I'm building are for a solar power station, so it's where I'm looking at much smaller, relatively speaking.
Yeah, I'd love to see what you come up with.
100 amps out of this thing. I want to be able to get a maximum of 2,000 watts. That's what my inverter is capable of.
That's watts and watts of power there.
Mm-hmm.
Okay, Pete.
Okay, let me switch the camera here. Whoops,
And that's
did
perfect.
it the wrong way. This is the correct way. Desoldering. This is a Heiko desoldering tool, and you turn it on, set to the centigrade temperature, pull the trigger, and it sucks solder out of this tip. And this is a hot air system. You turn it on, set the air temperature. I don't know how accurate it is, but you can set it like, for example, 260 centigrade is a good number for under soldering. But you can put a printed circuit board on this preheater, and underneath here is a ceramic heating element, and you clamp the board. I don't have a board handy. Here's one. So you take your board and you clamp it on there. You turn on the preheater and you bring it up to say 100 centigrade or 120 centigrade. Maybe, well, 100 is a good number. And then you take your hot air tool, and with this tool, when you pull it off of the holder, it turns the hot air on, and you can use this gadget to hold it in place, positioning this appropriately.
You use a vacuum gripper to grab the chip when you do it?
No, you let me put this back. So this thing here, I'll put this board in place. I've got to set the camera down in order to do that. So now the board is sitting in between these two little rails of aluminum, and it's sitting above this infrared ceramic heater, and that preheats the board. Then you can take your hot air with the appropriate tip, which fell off while I was demonstrating it. So you can take your tip, and there are several sizes that fit to go over different size packages.
Right.
And then you put the hot air on the portion of the board, and very, very, very carefully you pull off the chip in question.
And what do you use
With
to pull it off with?
What you use to pull it off with is a pair of decent tweezers. Let me show you these are my good tweezers. These are approximately $10, and they will pick up something extremely small. It doesn't really come across on the camera, but this will pick up an 0201. Actually, it'll pick up an 0402. With 0201, you get into weird problems where you can pick it up okay, you just can't set it down.
It
really
sticks.
The parts, it sticks. It starts acting like lizard feet or something.
So this is what I was saying before, there's a vacuum hand tool. In other words, a tool that is like a little suction cup, and you just place it right on top of the flat surface, and you
one of these
trigger on it, and it
It's
to the chip.
Like this.
No, that's a solder sucker.
Right, he's talking about like a manual pick and place, right?
Manual pick and place.
Oh, manual pick and place.
Exactly.
I don't have it where I can show it to you. I do have something like that, using a vacuum, using the vacuum side of an aquarium pump from memory. And another guy and I, we messed around trying to make a pick and place out of that, and it's feasible. It's feasible. I find tweezers a whole lot more effective. Just to continue, this is a reflow oven, and this big box here is a actual lab hood. So when you shut these doors and you run I don't have it turned on, but when you run it, it pulls air up through this activated carbon charcoal filter, and it goes right through that flue entrance and up my chimney. There's a large axial fan behind that piece of wood over there, and then there's a fan inside this. And so the net effect is that with this thing shut, the air is pulled in from the underside. It goes into the oven, It goes the exhaust air goes through the carbon filter, and the whole thing goes out. Nothing is emitted outside of the house. That's
Negative.
And it's negative pressure. Yeah,
Negative pressure.
I tested this by I took some of my wife's perfume, and I soaked a napkin and threw it in the middle of this thing, closed up the doors, came back an hour later or half an hour later, and there was no smell in the room. But if I opened up the doors and stuck my head in, it would knock me unconscious just about from the the aroma.
Is that a statement on the quality of your wife's perfume?
It's a statement about my ability to tolerate extraordinarily strong smells, because this was overkill. It was literally just total overkill. Anyway,
Pete,
this oven.
You're missing an opportunity here. You just need to say that your wife is stunning.
She is. She in fact, I could say some soliloquies about my wife until the cows came home. But this oven has got reflective material, infrared reflective material. Goes all the way around all of the insides. There's a very thin sheet of aluminum right here. I put the boards on top, and there's a thermocouple. There's actually 3 thermocouples, ceramic heaters, and it's a convection oven, so that it's circulating air like this. So that's the reflow oven. Then over here is a microscope, and I don't know how well you can see that, but this is the main body of the microscope, and the whole thing sits on this unit, so it can slide back and forth. It can also go up and down. It has a very, very great depth of field. So as you can see, the distance from the bottom of the lens, which is where this finger is, down to the bottom, there's a lot of clearance, so you can do soldering underneath this. And this is another carbon filter with an exhaust fan to pull the fumes and stuff through the carbon filter. And this is my baby. This is a Weller WXMP soldering iron, and it has, let me turn this off so that I don't burn my fingers. And I don't think I can do this one-handed, and I cannot. But the tips come off of the soldering iron, and they just sit here like this. You get a new tip, and you plug it in, and when you turn the iron on, it's going to show you how it goes in real time up to its normal soldering temperature. So now it's ready to use. And when you pull this tip out and you put another tip in, it reheats and it's ready to use in just a few seconds.
Wow.
This particular tip is so sharp. It's 0.2 by 0.4 millimeters from it's a chisel, and the edge of the chisel is a fraction of a millimeter in each direction. So it's so fine, you can put it on the individual legs of leaded, even fine-pitched leaded parts. It's a really, really, really nice soldering iron, and
how much did that thing set you back?
It's about $750.
Wow.
Yeah, the microscope is a similar price. The fume hood I found on Craigslist. It came from RTP. I found it on Craigslist for $100.
Wow.
The oven was made from a kit from oh shoot, I blocked their name. What's the name of the it's not Oleo, but it's like, no, what is it? I've got the name right here. Just a minute. Controlio. It's a Controlio kit. Using a plain Black & Decker convection oven to start with. It has solid state relays to turn the heat on and off, and but it's otherwise, so that's probably about $200. But let's see, what else is of interest? Oh, I was going to show you. Some of you guys might remember Fred Ebling. Fred was a design engineer who passed away a few years ago. And Fred, during the last few years before he passed, was designing special power supplies for driving LEDs. And he gave me this test rig. And what you are looking at is a 200-watt LED. That's the heat. Can you see the heat sink on the back of it?
Yeah.
Okay, now I'm going to turn it on, and you will not be harmed. Okay, but I have to look in a different direction. It's really bright. In fact, it's like, okay, if you've got a spare football stadium lying around, or a parking lot that needs lighting, this will do it. And I just, for the heck of it, set this up. It's kind of my my memory of Fred. You may remember Fred gave a presentation that's in the archive. He showed us one of the original breadboards, and he was a heck of a guy. Heck of a guy.
Yeah.
One other mention. He donated his electronics collection and some of his test equipment to SplatSpace, and it's all now installed at SplatSpace. So the next time you visit, give it a look. It's pretty amazing. Now to finish, I want to show you some executive decision toys, or tools, I should say. Like here is a magic 8-ball that you can use to make decisions. Let's see what it says. It says no doubt about it. You can also, if you get into a dispute with a client, you can take your own ray guns. You can also have a quick decision maker. Okay, and then finally, if none of that works, you've got a magic wand. You just wave it over whatever it is, and your problems will go away.
Geez, I wish I had half the space you got.
Well, that was only one room. This is the test equipment area, and let me turn the other light on. That's some of the test equipment. Well, this is some of the test equipment. This is my decent oscilloscope. I like that oscilloscope a lot. And then this is where I've been sitting. I was unsuccessful in using this computer, but I just have to show you this real quick. This is my workstation. Can you see the size of this thing? It's a PC, and it's the size of a book, but it has a 4-core Ryzen chip in it, and it gets everything done that I need. It's way fast enough, so I've been real happy with that.
How many cores?
4. It's about it's like a low end i5.
What did it set you back?
The box was about $230, and then I put 32 gigabytes of DDR4 RAM in it, and I put a M.2 solid state disk. I'm going to guess it was in the neighborhood of 500.
Cool.
And then I have to show you this is my server. This box, this is also a single single computer, and I'm holding the edges of it, so it's about 4.5 inches square. I've got the guts out because I just put ECC memory in it. It also has 4 Ryzen chips. I'm sorry, it has a 4-core Ryzen chip. It's got an M.2 drive, and then it's hooked up to about something around 10 terabytes. There's about 10 terabytes of disk storage hiding underneath here that you can't see very well. And that's the network storage system. That's it.
All right, motion to adjourn.
Second.
Okay.
All in favor? Recording.
Aye.
I
You,
Aye.
I.